we will explore the fuel system. First, we will start out with a system description. Next, we will go over the fuel tanks and the vent system. After that, we will review the refuel-defuel system. Then, we will take a thorough look at the engine feed system. Finally, we will cover the controls and indicators associated with the fuel system. The fuel system of the ATR consists of 2 integral wing tanks, the vent system, the fuel quantity indicating system, the pump system, the fuel distribution system, and the refuel-defuel system. Each wing tank can hold up to 2,500 kilograms of fuel. The wing tank incorporates a feeder tank located near the wing root. The feeder tank holds 160 kilograms of fuel and houses an electrically driven fuel pump and a jet pump. Feeder tanks are used to ensure that fuel is available for pumping throughout all flight maneuvers. The wing tank incorporates a feeder tank located near the wing root. The feeder tank holds 353 pounds of fuel and houses an electrically driven fuel pump and a jet pump. Feeder tanks are used to ensure that fuel is available for pumping throughout all flight maneuvers. The maximum fuel imbalance between the fuel tanks is 730 kilograms. 2 fuel lines pass through the wing center box, located over the fuselage. One line is used to cross-feed the engines, and the other line is used to refuel the left tank. 2 drains at the bottom of the box drain any fuel that may have accumulated in the center box. In addition, a vent line prevents any concentration of fuel vapor. A vent system provides a positive pressure on the fuel in the tanks when the aircraft is pitching and rolling. Each wing tank incorporates a vent surge tank located on the outboard section. Each tank is vented through an individual vent duct to the associated vent surge tank. A flush neck vent inlet provides atmospheric pressure to the surge tank and prevents the accumulation of ice on the surge tank inlet. Neck vents are also designed to resist lightning discharge. A float valve allows fuel to collect into the surge tank. In turn, fuel that is collected in the surge tank is returned to the wing tank through the associated vent duct. Another function of the vent system is to prevent an overfilling of the fuel tanks during refueling operations. In the event a tank is overfilled, fuel will be discharged overboard through the surge tank inlet. The wing tanks are normally refueled using a single-point, pressurized refueling system. In addition, there is a filling cap located on top of each wing tank that allows for gravity refueling. A refuel control panel located in the right main landing gear fairing controls refueling and defueling operations. The aircraft can be completely refueled in approximately 16 minutes. The aircraft is refueled by connecting a refuel line to a single refueling connector, which is located on the rear part of the right main landing gear fairing. Once connected to the refueling connector, positive pressure is applied to push the fuel into the wing tanks. Maximum pressure for refueling is 50 psi. When refueling, certain things should be avoided. Make sure no switches are operated, particularly activating or deactivating the ground power unit, or GPU. Smoking should obviously be avoided, as well as the use of cell phones. Also, take care not to refuel with any thunderstorms in the area. 2 solenoid-controlled refuel valves, located downstream of the refuel connector, control the flow of fuel to each associated wing tank. Once the refuel valves are opened, fuel flows to the associated tank. Fuel is dispensed into each tank through diffusers. Normally, The fuel quantity indicating system controls the closure of the refuel valves. The system closes the refuel valve when the fuel quantity in the associated wing tank reaches 2,500 kilograms. Each tank incorporates a backup high-level sensor located on the upper wing skin. These sensors control the associated refuel valve in the event of a malfunction of the high fuel level detection system of the fuel quantity indicating system. When the fuel tank is full, the sensor is submerged, and the associated refuel valve will be commanded to close. The aircraft can be defueled using the single-point refueling system. Defueling is accomplished by applying 11 psi suction to the refueling line and opening the refuel valves. Normally, each engine is fed by the feeder tank in the associated wing tank. This feeder tank is kept full at all times to protect the engine feed against negative or lateral load factors. The feeder tank will hold 200 liters of fuel. Each feeder tank incorporates an engine jet pump and an electrical pump. The electrical pump is capable of supplying fuel to one engine throughout the entire flight envelope. The electrical pumps are powered by the DC essential bus through the associated electric pump circuit breaker. An electrical pump and its associated engine jet pump can supply both engines throughout the whole flight envelope. One jet pump can supply both engines throughout the whole flight envelope, except when using Jet B fuel. Normally, the electrical pump is only used to start the engine. Once the engine is operating, the engine fuel feed is supplied by the associated jet pump, and the electrical pump shuts down. Fuel flows out of the electrical fuel pump and flows in two directions. The first direction takes it through a check valve and out to the low pressure, or LP fuel valve. During normal flight conditions, the LP valves are in the open position. An LP valve is closed only by pulling the associated fire handle. Electrical power from the hot emergency battery bus or the associated DC bus is required in order to close the LP valve. Fuel is also directed from the electrical pump through a check valve to a feeder jet pump. This pump pulls fuel from the main tank to refill the feeder tank. After the LP valve, fuel flows through a fuel heater, a high-pressure, or HP fuel pump, and then a fuel filter. After the filter, fuel flows through a hydromechanical unit, or HMU, and then into the engine. Within the HMU, some fuel is returned to the feeder compartment via a motive flow valve. This pressurized fuel provides motive flow for the engine jet pump. When sufficient pressure is present at the motive flow valve, it will open and allow fuel through to the engine jet pump. The motive flow valve is controlled by its associated pump push button on the fuel panel, which is located on the left side of the overhead panel. If the push button is deselected, the motive flow valve will not open. The push button is deselected when it is not pushed in. A portion of fuel is tapped off the engine jet pump and returned through a check valve to the feeder jet pump. The feeder jet pump transfers fuel from the main tank to the feeder tank, where it can be pumped by the engine jet pump and the electrical pump. A pressure sensor monitors the output of each engine jet pump. If the output of an engine jet pump drops below 5 psi, the associated electrical pump starts automatically, provided the associated pump push button on the fuel panel is in the selected or in position. Fuel pressure below 4 psi will be indicated by the illumination of the associated amber feed low pressure light. There are two other conditions that will cause the electrical pump to start up automatically. As mentioned previously, the automatic operation of an electrical pump will occur only if the associated pump push button is in the selected or in position. The second reason an electrical pump would automatically operate is during cross-feed operations. In this situation, both electrical pumps will automatically start provided, of course, that both pump push buttons are pressed in. The third reason an electrical pump would start to operate automatically is if the associated feeder tank is not full. The pump will start to run automatically when the fuel quantity in a feeder tank drops below 160 kilograms. This condition will be indicated by an amber fuel low LVL message on the engine and warning display or UD. A fuel crossfeed system allows either tank to feed the opposite engine. The two fuel systems are interconnected through a crossfeed valve. The fuel crossfeed valve is controlled by the crossfeed push button on the fuel panel. The crossfeed valve is powered by the DC essential bus. Fuel crossfeeding is usually used to correct a fuel imbalance. In this particular case, the left tank is lower than the right tank. To balance the tanks, you would press the crossfeed push button. When the crossfeed push button is pushed in, it will turn on both electrical fuel pumps. In order to start the crossfeed operation, turn off the pump in the tank with the lower fuel quantity. This will leave the tank with the most fuel with two pumps running. To stop crossfeed operation, turn the pump in the tank with the lower fuel quantity back on, and release the crossfeed push button. The panel on this screen is completely interactive, so you can start to balance the fuel. When the fuel quantity in both tanks are equal, terminate the crossfeed operation. Fuel crossfeeding is usually used to correct a fuel imbalance. In this particular case, the left tank is lower than the right tank. To balance the tanks, you would press the crossfeed push button. When the crossfeed push button is pushed in, it will turn on both electrical fuel pumps. In order to start the crossfeed operation, turn off the pump in the tank with the lower fuel quantity. This will leave the tank with the most fuel with two pumps running. To stop crossfeed operation, turn the pump in the tank with the lower fuel quantity back on, and release the crossfeed push button. The panel on this screen is completely interactive, so you can start to balance the fuel. When the fuel quantity in both tanks are equal, terminate the crossfeed operation. Another situation where you would use the crossfeed valve is for single-engine operation. In this situation, the operating engine would draw fuel from both tanks in order to maintain the fuel balance. In this case, you would not shut down either electrical pump so that fuel can be supplied by both tanks. This screen is interactive. A fuel quantity indication system calculates the fuel quantity in each tank and displays this information on a multifunction display, or MFD. Fuel quantity is displayed in terms of weight. The fuel quantity system operates on the relationship between the dielectric constant of the fuel and its density. The fuel quantity indicating system produces a signal that is proportional to the mass of the fuel in the tank. The signal is derived from capacitance probes located in each wing tank. There are 6 probes in each tank. The fuel quantity indicating system consists of 2 channels. There is 1 channel for each wing tank. The probes in each tank are electrically connected to the associated flight deck fuel quantity indicator. The 2 fuel quantity indicating channels are independent from each other. In the event of a failure of the electrical fuel quantity indicating system, the fuel quantity in each tank can be determined on the ground by means of magnetic level indicators. There are 2 magnetic level indicators for each tank, and they are accessed through the bottom of each wing tank. The readings from the magnetic level indicators are used to derive a fuel quantity from a conversion table. The markings on the magnetic indicators are in centimeters of fuel in the tank. The controls and indicators for the fuel system are located on the fuel panel. The fuel panel holds the controls for the electrical fuel pumps and the crossfeed valve. The arrangement of the push buttons and lights on the control panel, along with the lines, provide a simplified schematic of the fuel system. Each pump push button controls the operation of the associated electrical fuel pump and motive flow valve. When the pump push button is pressed in, the associated electrical fuel pump will automatically activate when the associated engine jet pump delivery pressure is low. This can occur either due to the engine not running or the engine jet pump pressure dropping while the engine is running. The run light illuminates green when the electrical pump is activated. In addition, run is displayed within the respective pump icon on the engine system page on the MFD. When the pump push button is pressed in, the associated engine jet pump's motive flow valve is commanded open. However, the valve will remain closed if sufficient fuel pressure is not available. Operation of the engine jet pump is determined by a pressure switch. The electrical pump will automatically shut off after 30 seconds when the pressure from the engine jet pump exceeds 8.5 psi. This explains why the green run light in a pump push button goes out after engine start. On the MFD engine system page, the word run in the engine jet pump is determined by a pressure switch. The electrical pump will automatically shut off after 30 seconds when the pressure from the engine jet pump exceeds 8.5 psi. This explains why the green run light in a pump push button goes out after engine start. On the MFD engine system page, the word run is replaced with a vertical green flow line within the associated pump icon. When a pump push button is selected out, the associated electrical fuel pump is deactivated, the jet pump motive flow valve is commanded to the closed position, and the off caption in the push button illuminates white. The motive flow valve is closed in order to stop the engine jet pump from operating. The LP valve position indicator is located above each pump push button. It indicates the position of the associated low-pressure valve. If you recall, this valve is only controlled by the associated engine fire handle. When the LP valve is open, the associated indicator will show a green inline flow bar. When the valve is closed, the associated indicator will show a green crossline flow bar. The flow bar is not visible while the valve is in transit. The schematic on this screen is interactive, so you can pull the engine fire handles to see the effect on the fuel system diagram and the fuel panel. An amber feed low pressure light illuminates when the fuel supply pressure is below 4 psi. This indicates a drop in fuel pressure downstream of the LP valve, due to a loss of both the associated electrical fuel pump and the engine jet pump, fuel starvation, or blockage in the supply line. When a feed low pressure light illuminates, a single chime will sound, the master caution lights flash, an amber fuel feed low pressure message is displayed on the EWD, and an amber feed low pressure message is displayed on the MFD. The crossfeed push button controls the operation of the crossfeed valve. When the push button is pressed in, the crossfeed valve opens, and both electrical pumps start to operate. This will cause both green run lights to illuminate. In addition, a cyan fuel crossfeed message is displayed on the memo panel of the MFD. When the valve is open, the flow bar in the crossfeed push button will be inline green. The crossfeed valve is closed by selecting the push button out. This will close the crossfeed valve, and the flow bar in the push button will be green and vertical. The flow line in the switch is only visible when the crossfeed valve is either open or closed. The control panel on this screen is interactive, so you can open and close the crossfeed valve at will. Fuel quantity is displayed on the MFD. The fuel quantity is color-coded. It is normally displayed in green. When the fuel quantity in a tank drops below 160 kilograms, the associated electrical fuel pump will start up automatically, and the fuel quantity is displayed in amber. Click on the Start Simulation button to see the system in operation. When a low fuel quantity condition is triggered, the master caution lights flash, a single chime sounds, and an amber fuel low level message is displayed on the EWD. Click on the Start Simulation button to see the system in operation. When a low fuel quantity condition is triggered, the master caution lights flash, a single chime sounds, and an amber fuel low level message is displayed on the EWD. Click on the Start Simulation button to see the system in operation. If the fuel quantity drops below 50 kilograms, the fuel quantity in the affected tank will be displayed in red reverse video. The quantity of fuel used on each side is indicated on the EWD. The fuel temperature readout is displayed on the MFD. Normally, the temperature is displayed in green. If the data is invalid, it will be replaced with amber dashes. The fuel LP valve is depicted by a circle on the MFD. The various possible positions are depicted on the screen. The crossfeed valve is also represented with a circle. It should be noted that when the crossfeed valve is closed, the line connecting the two sides of the fuel system is removed from the display. Each electrical pump is depicted by a square. The status indications for the electrical pump are depicted on the screen. The flow lines are depicted in solid green when the associated line is pressurized. However, only the outline of the line is visible when the associated line is not pressurized. As mentioned previously, the crossfeed line is not displayed when the crossfeed valve is closed. There is also an indication when there is a clog. A clog indication means that there is excessive loss across the fuel filter. This concludes the fuel module.